Welcome back. In the last session, we were looking for the problem number 5 and I told the answer 10K, right? And I hope this is clear. With respect to the definition RI, the voltage what you are applying and the current is entering into your amplifier, voltage by current is nothing but your input impedance. Then if you solve, we got a 10K, or qualitatively I can say the input impedance is nothing but the impedance seen into input port with respect to ground, because input port is defined with respect to ground. Then the impedance seen from this with respect to ground is nothing but, because negative feedback virtual current concept is valid, the same voltage is coming here, therefore with respect to ground is nothing but 10K. That is what we are getting directly. Okay, means simple. When you apply the voltage, the current, if you increase the voltage, current also will increase proportionally, that is proportional to like 10K. Okay, done. Now problem number 6. Problem number 6. In the op-amp circuit shown, assume that diode current follows the equation I is equal to Is into exponential of V by Vt. For Vi is equal to 2 volts, V0 is equal to V01. For Vi is equal to 4 volt, V0 is equal to V02. Then the relationship between V01 and V02 is. Okay. Now problem number 6. Circuit is let me take this as R is equal to 2 kilo ohm, and there is a PN junction diode in the feedback. This is V0 and this is Vi. Okay. Now for this problem, the diode current is given. What is diode current equation? Remember, okay, I is equal to, given I is equal to Is into exponential of V by Vt. Okay, and for Vi is equal to 2 volt, for Vi is equal to 2 volt, V0 is equal to V01. For Vi is equal to 4 volt, V0 is equal to V02. Then the relationship between V01 and V02 is, this is GATE 2007 for 2 marks. Option A, V02 is equal to root 2 V01. Option B, V02 is equal to E square V01. Option C, V02 is equal to V01 into ln2. Option D, V01 minus V02 is equal to Vt ln2. Okay. Now, how will you solve the problem? Okay, before that, see, if you consider any PN junction diode, okay, if you consider any PN junction diode, always the voltage is taken as forward bias voltage, then the current is always like forward bias current. Then if V is positive, I is positive. If V is negative, I is negative, but the directions or the signs are represented like forward bias PN junction diode. Then what is the relation between I to V? I is equal to Is into e to the power of V by Vt. That is what is given. Okay, but if you take typical equation, I is equal to I0 into e to the power of V by eta Vt minus 1. But remember, where V is nothing but voltage across a PN junction diode treating like a forward bias voltage, and the current I is nothing but current is flowing through PN junction diode, which is like P to N. Okay, this is the direction. That is what is given here also, where V is nothing but this is what is voltage V, and do it. First of all, whenever the circuit is given, I told you, right, negative feedback or positive feedback? Tell me, negative feedback or positive feedback? Negative feedback. Why? There is a path from output to input, right? That's why you are saying that negative feedback. Am I correct? But remember, yes, I agree with you. If you say negative feedback, then immediately I'll ask you a question. Then, what is the status of diode? What is the status of diode? Only when the diode is conducting, then only there is a path from output to input. If diode is not conducting, let us say diode is in reverse bias. If diode is in reverse bias, open circuit. If it is open circuit, it is simply open loop amplifier. It will not give you negative feedback because diode is not conducting, right? Then, first of all, how will you know that diode is conducting or diode is not conducting? I told you one technique. What is the technique to find the status of diode? Starting of the sessions or starting of the classes, the fundamental classes, right? I told you the technique is open the diode. Therefore, solution. Open the diode. Open the diode. Open the diode to find its status. To find its status. To find its status. Now, when you open the diode, just listen, don't write. I'm going correct by construction way. Means we are not just solving the problems blindly. There should be a reason to take any steps further. Okay. Now, this is what your resistor and this is your VI. Okay. Now this is ground. Now your diode is open. Open the diode to find. Okay. Now, but bring back your diode. But the diode is seeing the voltage. Okay. This is what your diode. But diode is not connected. But we opened the diode. Whatever voltage you see across open terminals, based on that we can say whether diode is in forward bias or reverse bias. But the technique to find the status of diode is to open the diode and find the voltage across open terminals. Then if the voltage across open terminals is greater than 0, let us say for ideal scenario or what it may be, forward bias, then only diode will be conducting. Less than 0 or negative, reverse bias, diode will not be conducting, open circuit. Okay. Now tell me, the moment when you open the diode, can I say your op amp is nothing but open loop condition? Your op amp is in open loop condition. If op amp is in open loop condition, then it is a comparator. We should not use virtual current concept. Don't say that this is 0, therefore this is 0. No, that is true only when the op amp is in negative feedback. That will be confirmed if diode is conducting. If diode is conducting, then we can go for virtual current concept. But first of all, we are trying to find whether diode is conducting or not. For that, we are opening the diode. It's like we are trying to connect the circuit. Everything is there, and we are trying to put the diode before keeping the diode across the open terminals. Then definitely you will get the open terminal voltage. Then in that case, your op amp is in negative feedback. Open loop condition. Then it is a comparator. Now let's see. If it is a comparator, right? It will compare the voltage between these two. And we know that plus is connected to ground, fixed. Therefore, what is the voltage at plus? 0. Now, if you know the voltage at minus, based on that we can say whether V0 is plus VCC or minus VCC. Okay. Therefore, now tell me, what is the current which is entering into op amp? Current entering into op amp is equal to 0. If current entering into op amp is equal to 0, the drop across resistor is equal to 0, then whatever you have, the same voltage you get here. Therefore, now what is this voltage? This is VI. Therefore, voltage at minus is VI, voltage at plus is 0. If this is what is the scenario, then it is a comparator. Now let's see. Case A. Case A. If VI is positive, positive means, therefore, this is what is positive. When VI is positive, then this is 0, which is more. Minus is more or plus is more, because this is a comparator, right? Therefore, minus is more, then output will be minus. Minus Vsat, or I can say negative. I don't bother about the magnitude, whether it is positive or negative, to find the status of diode. Therefore, now tell me, here, this is positive, now this is negative. Therefore, now what I am saying, this is positive, and now this is negative. P is connected to positive, N is connected to negative. Therefore, diode is conducting or not? Yes, diode is conducting. Diode is forward bias. Then we can go ahead. Now, case B. For example, Vi is negative, the input voltage is negative. When input is negative, tell me, now this is negative. When this is negative, compare 0 and then negative. Which is more? 0 is more than negative. Minus 1, 0. 0 is more. Plus is more. Then your output will be positive. Because plus VCC are positive. Now this is positive. Now this is negative. Okay? Negative and then positive. P is connected to negative. N is connected to positive. Definitely diode is in reverse bias. If diode is in reverse bias, then open circuit, then your op amp is in what? Open loop condition. Then it is a comparator. Then your output is V0 is plus or minus VCC. That is what is output. It is independent of the input voltage what you have. Now when diode is in forward bias, when diode is conducting with the equation I is equal to Is into e to the power V by Vt, then there is a path from output to input, then there is a negative feedback, then virtual ground concept is valid, therefore your op amp is in negative feedback. If op amp is in negative feedback, then virtual ground concept is valid. Then apply nodal analysis. Solve the equations, you will get the answer. Then find V0. This is the steps. Okay? Take it. That is the reason why, if you observe clearly, for VA is equal to 2, for VA is equal to 4, therefore VA is positive or negative? Positive. VA is positive, therefore negative feedback, we can apply virtual current concept, we can write nodal analysis, we can find V0 to VI relation, then we can get, using that equation, substitute V01, V02, try to get the relation between V01 and V02. Problem is over. Okay? Even though this is the problem, but I am explaining theoretically and I am explaining the procedure. See, we are going one by one, right? I am not explaining everything at the same time. Easy problem, little bit, therefore we need to cover all finally. Okay? Take it. I'll come in 30 minutes, 30 seconds. Over. Now we can solve the problem. I just explained the problem, and if you see the input right is 2 volt and 4 volt positive, means when it is positive, then we can go ahead with the procedure what is listed here. Therefore, VI should not be negative for this problem. If VI is negative, then your V0 is independent of VI, your V0 will be either plus VCC or minus VCC. It will be saturated because it will be entering into open loop configuration. Over. Okay. Now let's solve. Now, virtual current concept is valid, right? Therefore, for positive voltages. Therefore, what is this? 0. And Vi is positive. Therefore, for positive values of Vi, then apply nodal analysis. Current leaving from this node plus current leaving from this node. We cannot write 0 minus V naught by R. The current is already known to you, that is given. Let me say this is I, and the voltage across the PN junction diode is V. The voltage is V. Then the V to I relationship is already given. Then we can write the nodal analysis. Okay? Then tell me, current leaving from this node is equal to 0 minus Vi divided by R plus current leaving from this node, that is nothing but I, is equal to 0. Therefore, what is I? I is equal to Vi divided by R. But what is I? Current is I is nothing but the current which is flowing through PN junction diode. That is known to you. Given I is equal to Is into e to the power of V by Vt. Right? Therefore, this is equation 1. 1 implies, therefore, Is into e to the power of V by Vt is equal to Vi divided by R. Okay. What is V? Voltage across PN junction diode. We know that V is nothing but voltage at P minus voltage at N. That is the drop across PN junction diode, right? What is voltage at P? 0. What is voltage at N? That is nothing but V naught. Therefore, what is V? V is equal to minus V naught. Therefore, what is your Is? Therefore, Is into e to the power of V is nothing but minus V naught. Minus V naught divided by Vt is equal to Vi divided by R. Then if you write e to the power of minus V naught divided by Vt is equal to Vi divided by R into Is. Then apply natural logarithm, then you will get minus V naught divided by Vt is equal to ln Vi divided by R into Is. Then what is V naught? Therefore, V naught is equal to minus Vt ln Vi divided by R into Is. This is what is your output voltage. Don't bother about negative sign because input is applied at inverting terminal. That's why your output is having inversion to Vi. Therefore, that is fine. If you take only magnitude, Vt ln Vi divided by R into Is. Therefore, V naught is equal to something into logarithm of your Vi. This is nothing but what? Log of your input is nothing but your output with some factor. Therefore, can I say this is log amplifier? Yes. This is log amplifier. This is log amplifier. Now we got to know the relationship between V naught to Vi, right? Just substitute when Vi is 2, V naught 1, Vi is 4, V naught 2. Try to get the relationship between these two. Okay? Now problem is straightforward. Once you know the relation between V naught and the Vi, problem is over. Therefore, now V naught 1 is equal to minus Vt ln 2 by R into Is. Okay? V naught 2 is equal to minus Vt ln 4 divided by R into Is. What is log A by B? Log A minus log B. Log A minus log B. Log A minus log B. If you subtract that R into Is will be cancelled here. Therefore, you can do V01 minus V02 is equal to, if you take minus Vt common, then you will get ln2 from here minus ln4. What is ln2 minus ln4? Which is nothing but ln 2 by 4 1 by 2 log 1 by a minus log a, minus into minus plus ln2. Therefore, what is V01 minus V02? V01 minus V02 is equal to Vt ln2. What is the answer? Vt ln2. Option D. Therefore, answer is D. I hope everybody understood the procedure. There are similar problems to log amplifier, right? Then if you understand this, it is true. That's why tell me, mathematically also it is explaining something. If VI is negative, log of negative, undefined. Similarly, we know qualitatively that if input is negative, your output is not having any relation with respect to VI, your output will be plus or minus the power supplies. Therefore, it is not acting as a log amplifier. Only for positive input voltages, it is acting as a log amplifier. That is important point. Okay. And the relation between V0 to VI is this. Only for positive voltages. Mathematically also only for positive voltages we have log. Else we don't have log. If there is a PN junction diode in the feedback of your op amp, remember you will get logarithm action. I will give you 1 minute time. Try to complete in 1 minute. After that we will solve problem number 7. Over. Problem number 7. In the differential amplifier shown in figure, the magnitude of common mode and differential mode gains are ACM and AD respectively. If the resistance RE is increased, then problem number 7. Problem is see, this is direct coupled. Both the power supplies are given, plus VCC minus VCC, right? RC, RC. Now, input is applied. This is what is the input. This is VI. Okay. Basically, this is nothing but, according to our notation, V1, V2. V1 minus V2 is nothing but your VD, differential input voltage. Okay. Now, what is he saying? And this is what your V0 plus minus V0. Okay. And this is VI. Now tell me, this is what we had seen, right? But according to our terminology, this is V1, this is V2, right? V1 minus V2 or V2 minus V1, that is nothing but your VI or VD, and V01 and then V02, V01 minus V02 or V02 minus V01, that is nothing but your output voltage V0. That is what is given. Therefore, what is your AD here? AD is given, and we know, right? Therefore, what is AD? AD is equal to V0 divided by here VI, right? This is nothing but your CE amplifier gain, CE amplifier gain, right? If you take that, this is nothing but, if you take magnitude, which is nothing but HFE into RC divided by HIE, and it is independent of the bottom tail current source. Whether it is ideal current source, practical current source, or simply a resistor, doesn't matter, because the VE whatever you have, that is constant. If this is what is constant, then what does it mean? It is AC ground. Okay, if this is what is constant for AC signals, this is AC ground, then common emitter amplifier. Therefore, what is the answer? If RE increases, then this is what is differential gain. Then what is common mode gain? We got to know, right? If you take common mode gain, we took with RE, right? I told practical current source are value of RE. Then we already calculated that you will get minus RC divided by 2 into RE. But if you take only magnitude, you will get RC divided by RE. Therefore, now tell me, if RE increases, then what about your common mode gain? Decreases. If RE is infinity, ideal current source, if you take ideal current source at the bottom, right? Ideal current source, then what is your RE? RE is infinity. Your RE is infinity, open circuit, then it is simply current source. Then what your, therefore, then what your common mode gain? Your common mode gain will be 0. That is what I told before, right? Therefore, what is the answer? If RE increases, then your common mode gain will decrease. That's it. Option B, common mode rejection ratio increases. AD increase. AD is independent. ACM will decrease. But is speaking about common mode rejection ratio. Therefore, what is CMRR? CMRR is equal to differential gain divided by common mode gain. Tell me, if RE increases, then what about your common mode gain? Your common mode gain, which is RC divided by RE, right? Common mode gain decreases. If common mode gain is decreasing, what about CMRR? What about CMRR? Therefore, CMRR is equal to AD by ACM. If this is decreasing, your CMRR will increase. Therefore, what is the answer? The answer is CMRR will increase. Therefore, answer is B. This is GATE 2014, okay, for 2 marks. Done, right? Okay. Now, problem number 8. In the op-amp circuit given, the load current IL is 4 options. Okay. Let's see. Circuit is problem number 8. Circuit is and this is what is called IL. R1, R1, R2, R2. Therefore, asking for IL. Option A, I'm just taking options, you'll understand. Minus Vs by R2. Option B, Vs by R2. Option C, minus Vs by Rn. Option D, Vs by R1. Okay. Problem number 8, right? Okay. Now, tell me, negative feedback or positive feedback? It has both. Am I correct or not? It has negative feedback as well as positive feedback. Then, virtual current concept is valid? I cannot say. Unless which is dominating. Remember, if negative feedback is dominating, overall that will be negative feedback. If positive feedback is dominating, overall that is positive feedback. Now we need to find the type of feedback, means which is dominating. Yes, it has both the feedbacks, but which is dominating, right? Now, I told you, right, that I told you the technique to find the type of feedback. What is the technique? Open the loop and increase one terminal, come back to other terminal. If it is opposite, negative feedback. What does it mean? Negative feedback is dominating. If that is same as the change, then positive feedback is dominating, then positive feedback. Then we cannot use virtual ground concept. Okay. Let's see. This is to find the type of feedback, right? Before that, let me ask you some network example. Now, if you take example, right? Tell me there is a battery and this is RR. Let us say this is R. I can say for your understanding, this is 10 ohm and this is 10 ohm and this is 10 volts. Tell me what is the voltage? Instead of 10 ohm also, I can take 1 ohm, 1 ohm. That is also enough. But it is easy, right? This is 1 ohm, 1 ohm. Tell me what is the voltage here? Because out of 10, 1 will be gone, right? 5, therefore you will get 5 volt. Or I can say, if you see the current I, what is the current I? I is equal to 10 volts divided by the total resistance, 1 plus 1, 2, which is nothing but 5 ampere. Therefore, 5 ampere into 1 ohm, 5 volt, 5 ampere into 1 ohm, 5 volt, done. This is example 1. Now example 2. There is a battery. This is 1 ohm, this is 1 ohm, this is 10 volts. Let us say there is a switch where it is enabling 1 more 1 ohm, let us say. But switch is closed at time t is equal to 0. Therefore, now tell me what will be the voltage. If switch is not closed, then whatever you have 5 volt, this is what we got from example 1, right? When switch is closed, then tell me what will happen. Your 5 volt will increase or decrease. Your 5 volt will increase or decrease. Okay. Now I can explain. First of all, if you see the current which you are getting from your voltage source, that is nothing but I is equal to, tell me, 10 divided by 1 plus, what is effective resistance now? 1 ohm in parallel to 1 ohm, 0.5. Therefore 0.5 plus 1, 1.5. Therefore, you know, your current is now greater than 5 ampere. Why? Effectively, earlier the total load for your 10 volt battery is 1 ohm, 1 ohm, 2 ohm. Now, effectively 1 ohm, but it is 1 ohm in parallel to 1 ohm, 0.5 ohm. Therefore, 0.5 in series to 1, 1.5. Effectively, the load for your battery is, load means, okay, resistance is decreased, therefore current is increased, which is more than 5 ampere. But the 1 ohm is same in both the cases, then but current is more than 5 ampere, then the voltage across this will be more than 5 volt. Then this voltage will be less than 5 volt. You understand the point? Therefore, if you have 1 ohm, 5 volt, if you add anything in parallel to it, then effective current from your 10 volt will be increasing, drop across 1 ohm will be increasing, the voltage here will decrease. Okay? Let me apply that. Just listen. I'll give you time to write down. Now, let me apply. What is the technique? Open the loop. When you open the loop, right? Now, let us increase this voltage. When you increase this voltage, now I want to know, when you increase this voltage, I want to know what is the change here, whether it is increasing or decreasing. Only because of this, not because of anything else. Then if there is any other sources, make it inactive. Therefore, take it as ground only. Don't modify original circuit, you have to draw once again. Okay? Then, let us say this is what is increasing by whatever increase, that is 100%. Then, tell me, if this is what is increasing by 100%, what is the change here? This will also increase, but this is R1, R1. Therefore, voltage divider network. If 100% is increasing, then here 50% will increase. Therefore, this is what is increasing by 50% because voltage divider network. Now, what about this node or this node, right? Tell me, if this is increasing by 100%, if RL is not there, R2, this is also increasing by 50%, but RL is coming in parallel to R2. Therefore, R2, 50%, but R2 in parallel to RL. Then the voltage, here also it is increasing, but less than 50%. That is the example. If this is not there, 1 ohm, 5 volt. But if something is there, less than 5 volt. Therefore, R2, 50%. But R2 in parallel to something, less than 50%. Therefore, tell me, the negative terminal voltage is increasing by 50%, but the positive terminal voltage is increasing less than 50%. Out of this, which is increasing? Your minus is increasing effectively. Then when minus is increasing, therefore, if this is increasing, this will decrease. Therefore, overall, which is dominating? Your negative feedback is dominating. Therefore, this is negative feedback. Negative feedback. In the examination, no need to find, you can directly go ahead with the negative feedback, then you can solve the problem. If it is in negative feedback, then can I apply virtual current concept? Yes, I can apply virtual current concept. Then you treat it as VA, then both are same, then apply nodal analysis, then find IL, problem is over. Okay? Take the procedure. First of all, take these examples. I hope everybody understood to find the type of feedback, because it has both negative feedback as well as positive feedback. Then now we found which is dominating. We found that negative feedback is dominating. Therefore, overall this is negative feedback. Your op amp is a negative feedback. Then we can apply virtual current concept. Then apply nodal analysis. You'll get the answer. Okay. Now we need to find the current which is what is flowing through RL. Therefore, IL is nothing but the current which is flowing through RL. If you understand the steps to be followed, then once you know that nodal analysis and then finding IL, done. Problem is over. Only mathematical analysis, mathematical equations manipulation, that's it. Over. Now try to apply nodal analysis. Then you'll get the answer. Before solving the problem, let's expect what could be the answer. Okay, tell me what is the current which is what is flowing through RL, IL. Therefore, can I say your IL is function of what? Can anyone guess what could be the answer? The current which is flowing through RL, could be, I'm hearing some answers. See, because it is flowing through RL, therefore it is depending on RL, right? Okay, if that is what your expectation, that is fine. Let's see. Okay, therefore let's see the current which is flowing through RL. Let's solve the problem. Okay, can I erase all these things? Then go back to the original circuit. If I go back to the original circuit, this is Vs, right? I think almost the session is over. If time is not enough, we can continue in the next session. In the meantime, you try to solve. Okay? Now this is Vs. Okay? Apply nodal analysis. What is this? Let me call this as Va. And what is this? This is also Va. Let me call this as output voltage V0. Then apply nodal analysis at this node. Nodal analysis at this node. What IL is nothing but Va minus 0 divided by RL. Therefore, IL is nothing but Va by RL. Okay. What is IL? If you say Va, IL is nothing but Va divided by RL. Okay. Apply nodal analysis. Just follow me. Don't wait. You know this because we are doing this multiple times. Then apply nodal analysis at this node. Va minus Vs. Remember, if session is over, then we will continue in the next session. But you try to follow and then try to solve. R1 plus Va minus V0 divided by R1 is equal to 0. R1 will be cancelled. It is simply what? 2Va minus Vs is equal to V0. You can call this as equation 1. Now apply nodal analysis at the other node. Va minus 0 divided by R2 plus Va minus 0 divided by RL. Basically, this is your IL, current leaving from this node, plus Va minus V0 divided by R2 is equal to 0. Okay. You try to solve these two equations, then you will get the answer. Or we will continue in the next session. You try to solve. Okay. Thank you.